Okay, good morning. Welcome to today's panel discussion. I'm Ramin Esmaili from Softing, and I'll be your talk show host for the next half an hour. We will discuss Namur's open architecture, its potential use cases and applications of Noaa in relation to the process industry. On our panel, we have our partner, Erich Barnstedt from Microsoft. The partnership between Microsoft and Softing goes back as far as 2010, so more than 10 years that we're working together. And various colleagues from Microsoft and Softing have been working in working groups of the OPC Foundation, so that's where we know each other from. Also, I believe it was in 2016 that we had a joint demo at the SBS in Nuremberg, so quite a bit of history between these two companies. Erich, he's a chief architect for standards and Consortia, responsible for Azure IoT at Microsoft. He's an OPC expert and has quite a history of customer projects in the process industry. So welcome to the panel, Erich.
Thank you for having me.
Pleasure. And then we have Dr. Christopher Anhalt.
Yep, good morning.
So Christopher, my colleague here, he's a VP Product Marketing at Softing. He brings with him many years of experience in the IT and automation industry, and since quite some time, he's been working on the topic of industrial edge. And the third person in the round on the panel, Thomas Rummel.
Hello.
Tom, good morning. Tom is Senior VP, Engineering and Product Management at Softing. He has many years of experience in the process industry and has also been working in the standardization body of Noaa. And welcome to today's discussion, Tom. With regards to the audience, I really do encourage you to post your questions. We'll try to manage our time in a way that we answer them within the next half an hour. Anything which should go unanswered, we'll work on and we'll post it into the forum, into the back end. We'll stay in touch, and I'll want to hand over now with the first question to Tom. So Tom, let's start. Could you explain to us why is Noaa relevant for the process industry?
Ramin, thank you for the introduction. So let's start with explaining the current situation. So in the process industry, the automation systems to control the production process typically are closed systems. So only the data needed for performing the control tasks is available there. So this is not all the data which is available in the devices. So if you, for example, have hard devices, so only the analog sensor value is typically used in the control process. But these devices have much more information available, but that's until now not used. Additionally, the data is not available for use in modern information technology with IoT and Industry 4.0 applications. So these applications are used, for example, to monitor or optimize the production process or to monitor the assets installed in the plant. Now, Namur has identified this gap years ago and worked in the last years together with the ZVI to address it with the Namur Open Architecture. So that's what Noaa stands for. And it's now available as a series of Namur recommendation papers you can download from the Namur webpage. The Noaa concept creates a second channel to the data. So it leaves the existing automation system for process control as it is, and adds additional components to provide the data to the IoT applications. It uses OPC UA as an open interface to get the data and introduced a concept of the Noaa diode to ensure the security on this second channel. So the Noaa diode allows the data flow only into one direction, into the direction of the Noaa applications. So a Noaa application cannot directly change the control process. That means no risk for the availability or safety of the installed systems are introduced with Noaa. With the use of OPC UA, Noaa additionally defines OPC UA information models, which should be used to expose the data using the second channel. As an example, so for field devices, it defined that the PIDIM information model defined by the FieldCom group has to be used. So the components added to the automation system on the field device level for extracting data of foundation field bus hard or Profibus BA field devices provide their information to Noaa application over OPC UA. In future, if you have Ethernet APL enabled devices, they can include an OPC UA server directly and provide the data in the right format. In addition to the sensor and actor data, the one of the controller is also important for Noaa applications. Of course, like on the field device level, this data on the controller level can get collected by additional components and provided to the Noaa applications. All this different kind of data is then typically concentrated in an OPC UA aggregation server. So this server is already located outside of the core process control area, and it connects using the second channel to the OPC UA servers of the Noaa components and collects the data over the secure Noaa diode. The aggregated data then is provided over OPC UA or MQTT typically to the Noaa applications. So if you are reflecting the latest IoT technology trends, an industrial edge nowadays is perfect place to run this OPC UA aggregation server. So the industrial edge concept then allows you to run Noaa applications either directly on the edge together with the OPC aggregation server or in the cloud, which is then connected to the edge. Yeah, SoftInc has a long history over decades as connectivity provider in the process industry and in OPC UA. So we have experience with all the relevant protocols and automation systems. And as Rami mentioned, have worked as a Z4E member in the Noaa implementation project. So with all this experience, we have created our Noaa conformant products in the last years, and we will continue to extend this offering in the future.
Okay. All right. Thank you, Tom. And you talked about connectivity upwards, edge. And when I think about the cloud, I would think of Erich. So how can cloud help to implement Noaa, and what does Microsoft have specifically to address needs within the process industry when it comes to that, Erich?
Thank you, Raman. So first and foremost, Microsoft is a platform provider. So we have an Azure Industrial IoT platform. And as part of that platform, obviously, we have an edge runtime and we have a cloud gateway that we make available. The edge runtime is available free of charge and open source. And of course, we have OPC UA modules for the edge that readily connect to OPC UA servers, including the OPC UA aggregation server used in Noaa that Thomas just talked about. So then, with that functionality, we can get the data via MQTT with an OPC UA payload and a standardized information model. And that's the key part. It's standardized information model. It doesn't lock you in to the cloud for analytics. So in general, Microsoft sees itself as a platform provider to the process industry and a partner to SoftInc to enable cloud-based data analytics. And I mean, like you mentioned in the beginning, we've been working together for many, many years. The Microsoft Azure Industrial IoT team has its headquarters in Munich, just like SoftInc does. So, I mean, I can almost see your offices from here, right? It's not that far. And we've been working together for so many years. I think it's a great match, and together we have quite a few great successes under our belt. Just remember the Industrial IoT Starter Kit we launched, was it like 5 years ago? Things like that really help customers get familiar with Industry 4.0 applications and start thinking about, implementing new architectures like Noaa.
Great. Yeah, this was still before the pandemic, so this was at the SBS on location of the IoT Starter Kit. So
yes, exactly.
Let's see when we get back to that. A while ago, but hopefully we're back to that routine that we do less digital and more in person. And now let's take a more detailed look at IT-OT integration.
Ramin, sorry to interrupt you, but maybe I may ask just an additional quick question to Erich, which comes from mind unplanned, but anyway. I mean, the first question was, what's the Microsoft contribution? I'm just wondering, Erich, I mean, what is cloud doing? It's providing, let's say, infrastructure service. It helps to implement an architecture, and Noaa, as Tom outlined, as the name suggests, it's all about architecture. On the other hand, as we all know, the big cloud platforms, including Microsoft, provide really sophisticated algorithms on application level. How would you balance the two? What is really more relevant when it comes to making an offer for the process industry? Is really the architecture problem predominant, or is it to be solved? And then we talk about applications and what can be done there. How would you balance that?
So initially, obviously, a scalable architecture is required, and most people struggle with that, quite frankly. So we have reference architectures that people can adopt, which makes that a lot easier. And, you start small, you create a POC, and then you scale that same architecture. But very quickly, then, once they have the initial connectivity going, and, sometimes there are several network layers that need to be bridged with what we call nested edge, which is a technology where multiple edges can be daisy chained across different networks to reach the internet, right? So once all that infrastructure is in place and once all that connectivity is in place, very quickly then the topic shifts to analytics and applications that are run in the cloud for things that couldn't be done before on-prem, at least not at scale and not at a cost point where it becomes economical. For example, analyzing vast data sets, running machine learning on them, and then creating, that so-called digital feedback loop for getting the results of your analysis back to the shop floor to make improvements.
Okay, thanks.
Okay, Christopher, maybe you can share your thoughts on, let's have a more detailed look on IT-OT integration. And from your experience, what challenges do you see here for customers typically when it comes to integrating IT and OT in real Noaa projects? Please share your thoughts on that one with us.
Yeah, typical projects. I mean, to be fair, Noaa is recent. So strictly speaking, we don't really maybe have that much experience with Noaa projects in a narrow sense. But I guess when it comes to IT-OT integration, a lot of remains true what we have seen and learned in other projects. Let me maybe begin with a basic statement, quite obvious. A typical project is a brownfield project. So, of course, we have new factories, but in particular in the process industry, factories have a long life cycle, and the typical project is a brownfield project, which means, Tom, you spoke about all the relevant and important data which is sitting in devices. These devices that we see in brownfield projects don't offer standardized interfaces or easy to use interfaces to access that data. So the first challenge really is to add a layer. Sometimes we could call it gateways. I prefer the term data integration layer because it's more complex than just protocol translation, to access data in PLCs, process machine data, and access data sitting in actors and sensors. So that's the first challenge that customers need to face. And of course, they're working here within boundary conditions regarding network topology and security, as Erich also already mentioned. Then a second observation really is that And again, that's not specific for Noaa, but general. When you think about IoT, you have a central platform and you have multiple locations. And these locations have a different history, different technology, different production assets, also usually different skill sets in the personnel. So customers need to figure out a way how to connect one central platform to multiple locations. And that's a question on a technical architecture level. It's also a question on organizational level, what tasks, which responsibilities to centralize and what to do locally, as said, given that different locations maybe have different boundary conditions. And the third point, innovation cycles in IT are short. IT is driving the industrial IoT. I guess that's a fair statement. Innovation cycles remain short. Customers typically have a budget 1-2 applications to start their journey, but once they learn more, they want to twist them, or they have plans to add more applications, which means that also the IT-OT integration layer will change over time. Unlike, and that's now new in industrial IoT, unlike in the past, which was usually stable. So there are frequent reconfigurations for IT-OT integration that needs to be taken into account. Again, a process question: how do you operate? How do you manage your solution? So that's really a key question here, besides meeting technical requirements. So yeah, softing. So what does softing do to meet these requirements? First, we are traditional gateway vendor, so we continue, of course, to offer gateways, and we reacted to meet those questions on operational level, which means we now offer gateway components in a way that can be managed. The technical term here is Docker container, which is technology supported for Edge by Microsoft, by other players in the IT community. It's a well-known standard or technology used in many places, and we support it with our recent developments. There is a Edge connector product family, Docker containers to connect to PLCs without standard phases, extract data, make them available via OPC-UA. There is a SmartLink product family, which is also increasingly containerized to access data sitting in sensors and in actors, and again, make them available in a secure way via OPC-UA. And we also have an OPC-UA aggregation server to be containerized later this year. Tom, did you already decide on the final name? Is it Edge Aggregator? Not sure, or maybe that's
the core name, yes.
The preliminary name. So also for that component, key component, as defined by the Noaa architecture, we will have a Docker container shortly, so that it A, fits the technical requirements of the Noaa architecture, and B, can be managed and efficient by, tools, processes common in the IT world, supported by cloud, to operate the entire solution during the lifespan.
All right, great. As I move forward to the next question, I also see a question coming from the audience here, from a member of the VDMA, from Michael Putula. I hope I pronounced that correctly. So the question here is, do operators and buyers of process installations actively request or demand Noaa to be implemented? Can you estimate in how many installations it will be applied? So where are we standing with this? Very much related to the question of, how the process industry is moving forward. Where's the status? Any insights you can share here with us?
Yeah, maybe let's start me answering that one. So until now, you have several, let's say, implementation reference projects for Noaa. I think the biggest one is at the Bilfinger site in Frankfurt, which has created in this Noaa implementation project and shows really how you completely can realize the Noaa architecture from the sensor to the cloud. Also in the Achema Pulse, the OPC Foundation shows another demo setup. So we are on the level where we have all components available to realize Noaa, and now it's really the time where we will see first implementation then being done in real production scenarios. So if you see the softening product, so we are ready to go there. We also have a commercial aggregation server product, which is available since years. We have our different data integration components, as Christopher mentioned. So starting with hardware gateways to the Docker containers. So I expect really in the next year to see more and more Noaa installations being started. But as said, we are at the beginning, and from the technology, some of the concepts are still in a specification phase.
Yeah, I'll second that. I mean, we've been seeing, especially from obviously the end users active in the ZVI specifying Noaa, that they actually want to put this into production now. The first, PA-DIM enabled devices are becoming available now, and even if you don't have PA-DIM built in, obviously softening can do that translation for you, right? So that's not a requirement, but it helps. So from that perspective, I think over the next few years we will definitely see more and more production rollouts of Noaa in the process industry, probably starting in Europe and then also in the US.
Okay, thanks, Erich. What about the topic of security? To what extent is that being addressed? How secure is Noaa really? And do you see any risks when we're connecting cloud-based management on operation applications based on the Noaa architecture? Maybe this is a question which I want to send out to Erich.
Sure. I mean, in general, we've been doing industrial IoT now for 7 years. We thought about putting security measures in place. Noaa takes this to a next level, right? By really creating a second secure channel based on OPCOA, which has best-in-class security built in. And of course, because it's a diode, data only flows in one direction. The existing systems stay secure, right? You don't have to worry about, hackers being able to tap into the existing systems. So from that perspective, it's kind of a double, even triple security. Obviously, you have the cloud infrastructure security measures. You have your, firewalls, et cetera, et cetera. Then you have OPCOA with best-in-class security, encryption, authentication, all of that. And of course, you have this data diode concept on top of that. So it doesn't get much more secure than that.
Okay, great.
Maybe one thing to add. So even for, let's say, results of analytics, which is then going back to the control process. So the Noaa concept, in addition, also has their a functionality called validation of requests. So even there's another security validation step in the concept before you are really getting changes to the control process live, which have been calculated by the optimization. So it's really a very secure concept in that way.
Yeah. Maybe I can add a little remark here. I just spoke a little bit about the importance of operating concepts, and not meaning to spoil the party here, but Noaa, yes, of course, as we outlined or as we heard, it's a secure architecture, probably the securest architecture you could think of today. But it doesn't mean that the customer doesn't have to worry about anything else. Obviously, security is always a system property, including processes, the way how it's handled, managed. And that's something a customer needs to figure out nonetheless and deal with, which is not criticizing Noaa, of course. I'm just saying a secure architecture doesn't answer all your security-related questions.
Okay, thank you. Let's get also to the implementation side in relation of Noaa for customers in relation to the cloud. Does Noaa also support solution architectures where cloud is not part of the requirement, or is it linked to cloud to make the magic happen?
Do you want me to answer
Thomas,
this
do you
one,
want?
or maybe Thomas?
Yeah, Erich, please.
Okay, so I'll start and you can chime in. So obviously Noaa doesn't require the cloud. I mean, you can run the entire Noaa architecture on-prem. So that is definitely always a possibility. And quite frankly, for some analytics, it probably makes more sense to run this locally than running it in the cloud. The cloud has other benefits. The cloud gives you analytics at scale, including machine learning, that you don't really want to deploy yourself in your on-prem data center. It just doesn't make any economical sense to do so. So from that perspective, there are different use cases for the different locations where you run your analytics process or your analytics workload. In terms of, you know, I just saw a question there regarding, you know, what benefits Noaa has for cloud analytics and applications. I mean, in general, Noaa enables them, right? You can think of Noaa as, you know, breaking those data silos that, you know, we've had for many years on-prem in different systems down, putting them all into a single unified standardized information model and data format using OPC-UA, and then enabling that analytics in the first place. Without it, you wouldn't have any analytics in the cloud. It's that simple. So it's an enabling technology, right? So in terms of benefits, obviously, when you're doing your cloud analytics, security is the most important priority, right? And as we've already explained, security is built in, so that one is taken care of. Thomas.
Yeah, maybe I want to stress really these information models, because that's really a very important part of Noaa. And also if you see it in relation to analytics, so with Noaa, you really get the semantic information from the feed level or the controller level up to your analytics application. And I think that's the big benefit, as you mentioned before, that you have a standardized information model where the data is provided and you don't have to deal with all the different kind of data formats. It's really one independent from which vendor you get the data. And that's really the big benefit, of course, in addition to all the architecture we have.
All right, great. We're almost closing on the discussion here, so don't want to push my luck with us being cut off without finding enough time to let the panel, to let the participants know how they can reach us and what we're going to do next. So first of all, I do want to thank Erich. I want to thank you, Christopher. Thank you, Tom. Obviously, all three of you, including me, but you're the experts. I'm the talk show host, so you three are the ones who have a LinkedIn profile. You're the ones who can be reached for any further questions. Once this all sinks in, reach out. You can do this on the portal or via LinkedIn. We're there to answer those questions and to engage in further discussions beyond the half an hour we had today. Also, if we get any other questions within the chat, we'll make sure that we get those answers and that we upload the relevant documents to the portal, okay? And obviously, both Microsoft and Softing look forward to assisting you with your Noaa-related projects. And I really want to thank on behalf of the panelists, I want to thank from my side for engaging discussion and also for your attention to today's panel. And look forward to seeing people in person in projects with Noaa projects. Thank you very much.
Here, here.
Yeah, same here. Thank you very much. Thank you, Erich, for joining us.
Have a good one.
Bye-bye.
Bye.